Okay, I think we can start with the conference. Thank you very much. My name is Michaela Ksiklanova, and I'm a project officer at the Technology Agency of the Czech Republic. And I'm very happy to welcome you at the CHIST-ERA Project Seminar 2021. So last year we had planned to organize this conference here in Prague, but unfortunately due to the global health crisis, we were unable to hold it at all. So we have decided to do this online this year. Unfortunately, we couldn't hold it this year either. So we really hope that the program that we have prepared for you this year will fully make it up to you. So just to give you a brief overview of what CHIST-ERA Project Seminar is all about. This event aims to provide our funded projects with a broader picture of CHIST-ERA and the research it funds. We are trying to enable all of the participants to share their progress and achievements, and also to learn about other CHIST-ERA projects and other core topics that are funded within the CHIST-ERA framework. And also, we hope to be able to provide you with the opportunity to connect with other researchers and perhaps establish new forms of cooperation. Now I will briefly guide you through the program of the conference. So today's topic is focused on connecting the CHIST-ERA science with the society. So first of all, we will hear from CHIST-ERA success stories, which are past or nearly finished CHIST-ERA projects that have successfully managed to implement and exploit their research outputs. Then these success stories are linked through cross-cutting topics like responsible research and innovation, technology transfer, and open science. And apart from the success stories, you will also hear from experts in these areas who will give you some information on the challenges that you can encounter in those areas and how to tackle them. Later on, we will introduce the CHIST-ERA video contests, which, as most of you know, we have introduced this year in order to better promote CHIST-ERA funded projects. And all of you will decide about the winner, which will be announced on the last day of the conference. At the end of the day, there will be a networking session. So we will move from the Zoom platform to the Wonder platform, where all of you will have the opportunity to meet the other participants of the conference. Tomorrow we will split into 8 parallel breakout sessions. So each of those sessions will be guided by one facilitator from mostly the CHIST-ERA funding organizations. And during the first parallel session, there will be individual project presentations by all of the funded projects within each breakout. And in the second parallel session, you will jointly prepare a topic presentation with all of the projects within your call topic. Those topic presentations will then be shown on the last day of the conference. So there will be our main program for day 3. And in between, we will have a presentation on the AIC transition instrument, which is a new instrument to which CHIST-ERA projects are eligible. And before we start, let me just give you some brief information on the protocol of today's event. So first of all, please check that your name is in the following form. So your name, surname, and the project acronym, or if you're not a member of a project and the organization. And you can see it in the participants list. If you see that it's not in the correct form, you can also rename yourself there. I would also like to kindly ask you to turn off your microphone and camera during the plenary sessions if you're not speaking, but of course turn it on when you are speaking. On day 1 and day 3 during the plenary sessions, we will be live streaming this event to YouTube, and those sessions will also be recorded and shared publicly, so please take that into account. If you have any question, you can raise your hand via the reactions icon, and then you should wait to be called on during the Q&A session at the end of every presentation, or you can simply use the chat box to write down your questions, and those will be read out also after every presentation. In case you encounter technical difficulties, you can contact us via Zoom chat. So you can message directly my colleague Michal Kotera from our IT support, or you can email us at projectseminar@chist-era.cz. So with this, I would like to wrap up. Thank you very much for joining us here. I'm very much looking forward to the conference. And now I would like to give the floor to my colleague Florence from FNRS, who will give us some introduction into responsible research and innovation and the 6 dimensions that it covers. So Florence, the floor is yours.
I'm here. All right, and I will share my screen. Okay, normally you should be seeing my screen. Yes, so I'm just going to give you a brief introduction on responsible research and innovation and the actions that we at the CHIST-ERA consortium have taken in order to fulfill those obligations and those needs actually. So first of all, why responsible research and innovation? Well, Europe, the European Union in general, wants research and innovation in order to create jobs and find solutions to societal problems and be a knowledge-based society and continue to play its role in the world. But we have also need to show that research and innovation is in an interest of the people to justify the strong public investment that we are all putting into that field. And we have noticed that experiences such as GMOs have led to public resistance to technology, which is never good. And we also have had some research scandals, perceptions of biased research that have led to public skepticism and also a general defiance towards science in general that is actually taking place. Especially in this pandemic, we need people to trust in science. So this is why responsible research and innovation is important. And so the European Commission has developed research policies that stimulate new reflections on responsibility within science and innovation environments themselves, and facilitating a dialogue between not only the scientists and the innovators, but also with the public. And a dialogue is 2 ways, as you will see later on. So the fundamentals of RI are fourfold. First of all, avoiding the wrong impact of RNI on society in general. So the technical developments are usually framed by risk regulations, but this is especially true for CHIST-ERA project because we are emerging RNI technologies. The development usually takes place so fast that regulation lags behind, and this is why we as researchers and we as research funders need to really take responsible research and innovation aspects into our research in order to think about everything that can happen with our science. The point also is to create the right impact for RNI. So our societies have some grand challenges, but how can we make sure that what we are doing and what you are doing as a researcher contributes to what is good for society? And also, who are we? And I'm talking as a research funder, but also I'm asking the question to you, the researchers. Who are you to decide what is right and wrong? What are the right impacts and the wrong impacts of RNI on society? The researchers and even the research funders have a strong capacity to hype or at least promote their research and say that it is useful, but we often do not provide a neutral assessment of the benefits and burdens that the research can have on society. So probably by instilling a dialogue between the public, the society, and the researchers and the policymakers and everybody, we can have a stronger and more, how can I say, coordinated approach to the research and innovation. And also there are responsibilities of the researchers and innovators. So there are many different actors that are involved in research and innovation in general. What are the responsibilities of the individual scientist or innovator versus all the other actors, such as, for example, us, the research funder? So the easy approach to RRI is fivefold. They have structured it into 5 dimensions. Michaela mentioned 6 dimensions. It's a new dimension that entered, but it's rather hard to comprehend, so I avoided it completely. But it is a very more general aspect that I will briefly explain. So the 5 dimensions of RRI are gender, open science, science education, public engagement, and ethics. So in order to define them, here are the definitions. So gender is fostering gender balance, and usually, let's be honest, to close the gap in the participation of women into science and innovation, but also integrating the gender dimension in research and innovation content in order to improve the impact of the science. The dimension of open science aims to promote transparency and reproducibility of results and increase and widen the diffusion of knowledge. The science education is making science education and careers attractive for young people. This is a very ambitious goal, but it targets to improve science and technology literacy in our society. Public engagement, the creation of inclusive, participatory, multi-actor dialogues between not only the researchers, the policymakers, but also the industry, the civil society, NGOs, and citizens. And of course, ethics. I think a lot of people already know ethics and probably open science as well. So ethical research conduct implies the application of fundamental ethical principles and legislations to scientific research. So these are the definitions of the 5 dimensions, but we shouldn't view them in such a broad view, and we can open up our thinking. For example, on the term of gender, we can think about gender, but also diversity in general, and assessing the way in which the research may influence differences in society, for example. For open science, it's not just putting all your data on an open data repository, but it also can impact on your research, well, how you view your IP issues, for example. In terms of science education, it's good to bring young people to your field, but maybe it is also about thinking about learning about other disciplines. And so here comes the idea of also multidisciplinary research that can be conducted. For public engagement, as I have said before, one-way dissemination is not enough. You need to learn from the public and other stakeholders in order to embed your research and have this virtual cycle of getting the feedback and then improving your research and getting feedback and improving again. And ethics is not just about breaking the rules or following the rules. It can also mean a reflection on the potential ethical issues of the research. Is there any impact on privacy on long term, for example? This is especially true from some of the CHIST-ERA funded projects. Can there be dual use of the research? Are there impacts on human identity done via this research, etc.? So this is a broader reflection on what should be thought of when you think about RRI, your research, and the project. So this is all very nice. But it's not very concrete, I can attest. And so what have we put in CHIST-ERA in order to promote RRI? So the CHIST-ERA consortium, I think we can say, is a strong promoter of RRI. We have implemented in CHIST-ERA 4 some very concrete actions, which you will learn on later during the day. For example, we have strong actions in open science, and my colleague Ahmad will talk to you at length about it and tell you everything that we have put in place. We also have some actions in technology transfer, and we have seen before that this has a direct influence on for example, open science and how this dimension about public engagement, societal responsibility, societal awareness. And we also have actions in research communication. So we have CHIST-ERA usually promotes research results from funded projects, and we are always welcoming success stories or things to promote. So if you have any, please send it to us. And I will introduce it a bit later during the day, so you'll have to wait a bit. But we are also in the area of public engagement and public science education, put in place a short video contest in order to give some promotion on your projects, the results, and then in lay terms explain what you are doing. And I'm just going to finish here. It's a very short presentation, but as I told you before, there's going to be a lot more concrete actions being detailed a little later. So there are two very interesting websites that teach you all about RRI. So the RRI tools, or Horizon Europe, has developed, has had a project on RRI, and you can find on this website different tools, different assessment tools in order to assess your RRI-ness of your project. And also, I think it can be very interesting for a CHIST-ERA project. New Horizon has also developed a thinking tool for society readiness of your project. And so you can enter the data of your project and see how RRI is applied. It gives you tools to links in order to know what to put in place in order to make it more RRI compliant or RRI safe, if I can put it that way. And so this is a very interesting tool that can be used at any stage of your project. So I encourage you to check it out. And I am ready for questions if there are any.
Okay, thank you very much, Florence. I don't see any raised hands or any questions in the chat so far.
All right.
So yes, we can maybe come back to it later during your second presentation if any questions arise in between. And now I will give the floor to the next speaker. Thank you very much. So now we have the first success story by Heiko Schult from the project Emotion. Heiko, the floor is yours.
Yeah, just a second until everything is set up. Now you should be able to see my slides. Thank you for the introduction, Michaela, and also thank you for the invitation. I was asked to briefly report on activities along the lines of responsible research and innovation we've did in the context of a past CHIST-ERA project, which is the project iMotion. And basically, most of the activities I will report on happened after the end of iMotion under the term retriever. So we'll introduce both. iMotion is a project that has been funded by CHIST-ERA in the IUI call. This was the Intelligent User Interfaces call from 2014 until 2016, where the Swiss funding agency kindly added one more year for our project activities. It was a 3 partners project. So together with us, we had the University of Mons from Belgium and Koç University from Istanbul. And as I said before, I should switch on my video, just realized. And as I said before, most of the activities I will report on today happened after the end of iMotion. The continuation of iMotion is called Retriever, and Retriever is a project and also a system which is open source. It's a multimedia search system consisting of 3 essential parts. One is a multimedia database, or we have 2 different multimedia databases, Adam Pro and CottonTail-DB. There is a retrieval engine we've built in the context of iMotion and extended subsequently, which is called Cineast. And we have several different front ends, from a traditional web-based front end up to virtual reality and augmented reality front ends. Before I'll come back to the activities along the line of responsible research and innovation, and I would like to briefly introduce the project and give us some ideas what the project has been about and is about. And with this, I'd like to apologize to all the members of the funding agencies because they have seen these slides a couple of times already in previous CHIST-ERA project seminars. So the main focus of this project of iMotion and Retriever is to deal with large volumes of multimedia data. So you might be exposed to such multimedia data in your private life, in your business life, in your professional life, and you're collecting more and more digital multimedia objects, images, videos, audios, 3D objects, and it's becoming more and more difficult to organize this content and to find a needle in the haystack if you're looking for certain content. And what you traditionally do is you have your multimedia collection, say an image collection, and you're searching based on keywords. This is what you do typically, for instance, in the Google image search, which is a bit difficult because it requires that all the content is properly annotated, and due to the sheer size of objects in your collections, you will hardly do this. So after 2 weeks vacation, well, at least back in the days where we had the chance to physically go on vacation, after 2 weeks vacations with very many photos you took, you will hardly annotate them individually. So this is the most common search paradigm, but still limited. A few years ago, Google and others have started with so-called query by example. And query by example means that you provide a query object and you're looking for similar content in your collection. So for instance, this guy is looking for a particular photo, in this case, penguins. He goes to his search system and asks for similar content, visually similar content. Well, in this case, not in all cases, semantically similar content. This is a completely different approach, but still a bit problematic, because if you convert this into web search, so in query by example, you have to provide a full example of what you're looking for. If you apply this to web search, you would have to specify a complete website when you're looking for a website, or a complete PDF document when you're looking for a PDF document, which is not what is happening in practice. So that's why we thought of adding new different query modes and different approaches to search in multimedia. And one approach is query by sketch. We do a hand-drawn sketch either from scratch, or you take an existing object and simply add a sketch to describe what you're looking for. And this is closer to what happens in web search, because now you can concentrate on the essential elements of what you're looking for. Or another approach, especially in video, is to specify the motion of objects. So for instance, I know that I took a video of my family, and I know that my daughter was wearing a red dress and was walking from left to right through adjacent frames in the video. Or if you're looking for some sports scene and video snippet, you might sketch an interaction between players in sports and hope that you find a retrieval system that is able to search for that. Or of course, you can use deep learning to analyze the content of your image, video, 3D audio collection and use the semantic concepts. And even more, you can also try to represent semantic content and concepts with spatial information and ask queries with so-called semantic sketches. And semantic sketches organizes concepts on a particular location on the image. And you can ask for a query for time and space. So a particular location where an object has been captured, or a particular time when this has been the case, which is particularly relevant for mobile search. So if you're searching on a mobile device, and ideally you combine all these. This was the starting point of iMotion and subsequently the activities on Retriever. And this is a current summary of the search support Retriever offers. Of course, it knows query by text. It can do query by example. We can sketch objects and ask for similarity based on sketch. We can apply semantic concept detection and use this. We can apply motion queries in videos. You can use audio similarity. You can query by time and location, as I said before, especially on mobile devices. Very recently, we have added query by gesture. So doing a hand gesture, and you're looking for videos where the same hand gesture has appeared. And of course, semantic sketches. And all this can be mixed and matched quite flexibly to refine a search step by step. And the systems that have been built consist of two parts. One is an offline part and one is the online part. In the offline part, you have your collection, images, audio, video, 3D. You analyze your collection, you extract characteristic features, either low-level features or semantic features. You represent each object of your collection via a set of high-dimensional feature vectors. These feature vectors are stored in a database, and anytime a query comes in, you can select your favorite query mode, you select your favorite features, then the query is represented in the same feature space, and similarity search is nothing but finding the nearest neighbors in your feature space. So then at the end, you will receive a list of objects that are relevant. So this is what Retriever is about and what iMotion has been about. Now let's come to the question of responsible research and innovation. Michaela has given us the 5 dimensions and has asked to report on activities along the dimensions Florence has just introduced previously in her presentation. So one activity is on science education. And we realized that being a university project, it has been extremely helpful to incorporate students very, very early on in research and development activities. So within our university, we have managed to very quickly create a community of students that are supporting our project activities in the form of student projects as developers, being in the form of volunteers when it comes to the evaluation. And such a community is very helpful for making a system and a project successful. And I just learned that you have a video competition you will announce today. A few years ago, we decided to do something similar for student projects. We also have a kind of video competition where students are supposed to prepare a video on their student projects so that they can show, not just at university, but also to their friends and families on what they have been doing. And we realized that it's good education to think about how you can sell research and development activities you're doing to a broader audience. We also tried from very early stages of the project to present the results to the general public. And well, this lies in the very nature of our activities, multimedia retrieval, which can be demonstrated and showcased quite easily. And we have taken quite some efforts to be also visible in the general public. So a couple of years ago, for instance, a local art museum, Kunsthalle Basel, has organized a special exhibition. So it was a kind of meta exhibition. They have opened their photo archives. And it has turned out that since the beginning of the art museum, they have documented all the exhibitions with photos, with analog photos, which have been digitized in the meantime. And the exhibition, which was called Exposed Exhibitions, has shown all the archive photos of previous arts exhibitions. And they've asked us to participate as well with a retriever station. So we had a particular retriever deployment where we uploaded the entire collection of photos from the art museum and have asked students, the participants and the visitors of the museum to go to Retriever and to search for content, so for photos from previous exhibitions, which was quite a success and has given us quite some visibility in the local community. Another event we have been participating since 3 years now is the Museums Night in Basel. So this is one night, usually in January, where all the museums are open from Friday evening until Saturday morning. Unfortunately, it has not been taking place this year for obvious reasons. And we teamed up with the Historic Museum in Basel. This is one of the museums that has very many artifacts, more artifacts than they're able to show on their premises. So they have digitized some of these artifacts, and we have set up a virtual museum based on Retriever where this content has been shown. And at another event, this is the Fantasy Basel Fair, we have even added a VR interface to this virtual museum so that you can walk through a virtual museum with VR equipment. And all this has given us very valuable feedback on features of the system, but also very interesting insights on how to sell research results to the general public. Another aspect we realized from the very beginning of the Retriever project, also in our motion, is the gender imbalance we usually find in computer science. So even though we had quite a large number of students contributing to our project, at the beginning we only had very few female students. And we only had very few female students in general in computer science. So based on discussions we had in the Retriever context, and in the context of projects of our group on how to increase the number of female students, we recently have started with a dedicated association, which is called Your Computer Science, to promote diversity and support especially female students by dedicated mentorship programs. And the first results are extremely encouraging. And the number of also female contributors to our project has increased significantly. The second topic I was asked to comment about is technology transfer. Already from the very beginning of the Retriever project, we have decided to make everything open source. Consequently, source code, data, everything we can publish open source has been published open source. And this has opened up a very interesting perspective because we have been selected 3 times to participate at the Google Summer of Code initiative. So to those of you who haven't heard about Google Summer of Code, this is an initiative sponsored by Google to promote the development of open source software. Open source organizations can apply, and once selected, Google promotes these projects. Google invites students from all over the world to apply, to participate in these projects, and the students are reimbursed for their contributions by Google. So in 2021, this year, we participate for the 3rd time with Retriever, and it feels good to be listed in the list of organizations right next to the Wikimedia Foundation, for instance, as a participant to GSAC. And we realized that due to these participations, we have managed to increase the visibility of the project, but also to make the community of developers bigger and more diverse. There are some challenges we've come across, and one challenge is that being a multimedia retrieval system and being a project developing a multimedia retrieval system, making available source code is not sufficient. So simply with the system, you can't do anything. You need to have content. So one of the early activities was to instruct people on what they need to do to use Retriever for their own image, video, audio 3D collection as a first step to start up using the system. And we've also compiled a sample collection that can be used for, well, working with Retriever. And this collection is also published open source, and we have focused on collecting and harvesting objects that are all available under Creative Commons license, so objects we can easily share. And last but not least, the third part is open science. And open science is partly open source, as I mentioned before. Everything is under an MIT license available to the entire community. The sample collection I mentioned consists not only of content, but also of metadata. This is released to the public as well. It is being distributed by NIST, the National Institutes for Standards and Technology in the US. So we've teamed up with them because they are using it for several evaluation campaigns. And we also realized that evaluation campaigns in the multimedia retrieval area are very important. And we realized that campaigns to some extent suffered from system support. So one of the recent developments we did is to develop a distributed system for the evaluation of retrieval systems and for running evaluation campaigns, which is called DRESS. And there's one more slide on DRESS later on. Cost is another important aspect as well. Unfortunately, all these activities have started after the end of CHIST-ERA, so all has been funded with regular funds from my university. There is no CHIST-ERA funds that went into it, not because CHIST-ERA was not willing to fund, but simply because CHIST-ERA laid the foundation for all these activities, and everything along the lines of what I've presented has happened later on. Now let's quickly take a look at very recent activities we did in order to support work in the community. And I mentioned before that retrieval campaigns are important in the multimedia community. Especially multimedia retrieval is a bit difficult because it's largely interactive. This is something that can hardly be automated. The human has to be in the loop, which makes campaigns quite difficult. There are existing ones, so TrackWit, for instance, which is run by NIST in the US. It's very comprehensive with very many sub-competitions, but it is not interactive. And well, they have certain types of video retrieval, but everything is running in an offline mode. There is a dedicated video retrieval competition, which is called DBS, which annually takes place together with the Multimedia Modeling Conference. This is interactive, but the downside is that it has to be on-site. So people have to travel to the place where the MMM conference is being organized to participate with their system to the evaluation campaign. And it also suffered in the previous years from a collection which was rather small, but at the same time, it had an interesting breadth of different challenges to be solved. So one is called visual non-item search. Participants are shown a short snippet of video, which they're supposed to find again in a large collection with their tool. Textual non-item search, the same with simply a textual description. So you have not even a visual clue on what you're looking for. And the talk video search, this is a search for certain concepts in videos. And another campaign is called LSC, a Live Log Search Challenge, which is organized yearly together with the International Conference on Multimedia Retrieval. The content comes from a live logger, a person who records their live entirely, both visually and in terms of the audio signal. This is anonymized visual information, so anonymized images. This is a campaign, retrieval evaluation campaign that is interactive, but it suffers from a small collection and also the fact that everything is on-site. We started a while ago with Retriever and with iMotion to participate to these competitions, have been quite successful, but we realized that there are some limitations. And we have tried to address these limitations and to help the entire community to overcome them. One, as I mentioned before, was the lack of sufficiently large collections for doing evaluation campaigns. So we have designed V3C, which is the Vimeo Creative Commons collection, a video collection of almost 5 terabyte of data, more than 3,800 hours of video, which we have published, made available, and it is used since 2019 at TrackWid and at VBS. And we have compiled this collection in such a way that it comes with 3 different parts, and the 3 different parts allow to gradually increase the complexity of campaigns over the years. So for 3 years, TrackWid and VBS have agreed to use the first partition with C1. After 3 years, then the second partition will be added, so to double the size. And then after, again, 3 more years, the third partition will be added, which then gives a collection of almost 5 terabyte of data. Another limitation I mentioned before was the system support for retrieval. And we have developed DRESS basically a year ago, and over the summer 2020. We have developed DRESS, a distributed retrieval evaluation server, which is open source as well. And this server has the nice consequence that it can run retrieval evaluation campaigns on site, but also offline. So remote interactive retrieval evaluations. It is used since 2020 at LSC and will be used from this year onwards at VBS. So this is a system where all the tasks are being presented and where the results and the submissions of the participating systems are judged. And we have used DRESS for some try runs last summer for a truly remote evaluation where we teamed up with a research group from Charles University in Prague. They have implemented a system which is called CHIST-ERA, which is one of the, in air quotes, competitors to Retriever. And we have organized a remote evaluation where everybody was at their place. So the CHIST-ERA team was located in Prague. We have been in Basel. All systems were shown the same challenges, and all systems had to do the same tasks. It was a very successful try run, and we realized that we could scale this to bigger sizes, to bigger communities, so that more than just 2 systems can participate in such a remote evaluation. We realized with the pandemic and with all the travel restrictions that all the on-site events maybe are not the future, and the more we can do remotely, the better. So no travel would be involved anymore. We could have higher frequencies of such evaluation campaigns, organize evaluation campaigns of longer durations, and at the end, the entire community will benefit from that. We realized that with such a system, more standardized evaluation metrics can be implemented and can be enforced even across different evaluation campaigns. And also, the reproducibility of results will be supported with that, which is a bit of a contradiction. I mentioned before, in multimedia retrieval, the human is in the loop and is taking over a very important role in the entire process. But the more standardized the entire setup is, the more standardized the tasks are, the more standardized the reporting is, the more also the results are reproducible, and the more objective these judgments are. So bottom line, over the years, we realized that there is some investment needed in order to support entire communities with tools, with data, with systems. And we realized that all the effort we have invested really paid off, and it was not effort invested for an individual project, but for an entire community. And maybe this serves as a kind of success story or a kind of role model also for other communities, not just to focus on their own research project, but also to focus on supporting the infrastructure for the entire community to better organize their work, to better compare the results, to better reproduce the results, and to better share their research results. With this, I'd like to conclude this presentation, and I'm of course happy to answer your questions. Thank you.
Thank you very much, Heiko, for this very interesting presentation. I think it was inspirational for all of our participants. And as I see in the audience, there are no raised hands. So in case anyone wants to ask Heiko about anything about this presentation, you can do it now. And okay, so still no questions. So I think thank you very much, and we can move on to the following speaker. So now I would like to welcome Silvia Giordano from another CHIST-ERA project, Uprise IoT, who will present a second success story.
Okay, thank you very much, Michaela. And as she introduced me, I'm Silvia Giordano, and I'm the coordinator of the Uprise IoT project. The Uprise IoT project was project in the private and security topic of 2015, so we started in 2016, and the objective of the project was mainly to create awareness and control of IoT data in the users to have a more privacy-aware world. Clearly, we were not alone in this project. We were 4 partners, and together with us of SUPSI, we also had CHIST-ERA with a group of Claude Castelluccia, and we also had Euracom with a group of Rafik Molva, and UCL with a group of the team of Mirko Musolesi. And as you can see, we were 4, let's say, ICT research teams, but into different research directions, where Euracom and CHIST-ERA are mainly in security and privacy topic, while SUPSI and UCL are more in behavioral, in human behavior research topic, and in that sense also close to this user-centric vision of the project. And the idea of the project, the main motivation of the project started from the observation that IoTs are getting more and more deployed around us, and clearly if privacy is not considered from the beginning, there could be a risk to stop or block down this spread of IoT devices. And the idea for us was, as ICT researchers, was to say, okay, we need to have privacy by design from the beginning, and to have a way to give to the user the possibility to control such IoT generated data already from the design of the story. And at a given point, we started to ask to ourselves, but it's really true that user needs to have this control on such IoT data. It is exactly this, the role that we do have as ICT scientists, or there is something else, some other type of technology that we should provide to the society, to the community. And actually, what happened it's quite funny. But in the meeting of the first year, it was still time where we could have physical meetings. So we were all around the table, and we started to discuss about the fact that we were developing some solution, especially for mobile phones, that were sort of disappearing after a very short time, because as soon as Google or iOS were coming out with a new software version, with new open system version, new system version, clearly we were no more able to use our solution. So even if we were developing some IoT solutions, the solution we were writing were valid until the software was still the same. But after a minor change, we were no more valid. And then we say, okay, so we need to do this sort of run with the tech company to try to modify what we are doing every time, because they do a change, and then we have to change again our software. A legal scientist who told us, well, but I don't think that our role as scientists is to give the control to the users, or better, it's not our role to try to find a solution that is sort of patching the law by Google or by Apple in order to give to the user a control on that. Because this is something that the big tech themselves have to do. It's not us who has to do. What we should do is to do some experiment, to do some data collection in order to show that there is the problem awareness around, in order to inform all people what is happening. And that's exactly what happened to our project. We try to modify our objectives. So basically, sorry. So we modified our objectives. So what it happened is to instead of creating to giving control to the users, we say, okay, in the project we need to create awareness. And the reason behind that is the fact that it is the deployment of IoT cannot be blocked by the fact that people do not control their data, because if they don't know that they have some privacy issue with their data, the real problem is whether the user knows about the privacy issues with their data or not. And the fact, the objective, real objective that they then, from this point on, to achieve within the project was to have public engagement, to create a dialogue with the public, with the people on privacy. And then we tried within the project in Uprise IoT, so until last year, to put the basis for this. We created some tools and apps that were shared with people in order to see whether we can collect their impression, their feelings. We can get also, we could understand how we could have awareness with them. And we also have several publications, and overall we had a spin-off project that was funded by the Swiss National Science Foundation, where we try to continue this this story. So first of all, what we made in terms of responsible research and innovation in applied IoT was to really create some research that can be both transparent but also can be reproduced by everybody. And in that sense, we wanted to increase the diffusion of the problem of privacy and create a more awareness of privacy within the scientific community, but also to give hints to different audiences, like participating to conferences and to public discussions where we could reach different targets for this problem. We also started to put the basis for science education in this direction, especially with young people and with their educators. And in this sense, I will show you later what we are doing right now with the new project. And also, we really believe that was essential to have this public engagement. So basically, we involve the people in all our experiments, not only for testing whether our results were good or not, but mainly to get their feedback and to see whether the message that we were building was something positive that was possible to give then, especially to policymakers, because our idea was that we don't have to create the control tools for privacy, but we have to create evidence of the problem and to give this evidence to the policymakers so that they can take actions in order to react to the problem, to the issue. And clearly, ethics and governance comes as a consequence to the previous points in this topic of privacy. And one step that we made in that direction was exactly to have to involve in our discussion communication and education scientists, and as I said, to have legal scientists for the story, for making the story more solid and to reach the policymakers in the right way. As I say, we were mainly ICT scientists, and we tried to create what I say that was this science to reproduce. And we started with this Uprise IoT project, and we are continuing right now with this new project that is called MAPA. And this is exactly in this direction where we try to grow a new generation or a new awareness within the society. So we target as main group, especially in this MAPA project, we target the young people because we had to select a target, and we believe that we need now to educate the new generations that are clearly using the mobile phone like we were using any simple tool in our early age, that this tool can be dangerous if not used in the right way. And that's the important point that we are trying to pass, to create, to make this awareness in the society. And as I say, we created this set of multiple apps because we wanted to engage the public, to give to public some tools that they could play, they could use to realize that there is this risk that there is this that their data have been collected, are collected, that have been collected, and can be used in a even in a malicious way, so that we can create some evidence for the policymakers and involve other stakeholders like NGOs and the industries to create a societal awareness of the problem. And as I say, we have several tools and applications, and a first one is called Mockingbird, that is a mobile app that was used to give to the user the feeling of what data are collected by the applications that are running on its mobile phone. So basically, most of the people are using mobile applications on the mobile phone without having real understanding of what they are doing, what these applications are doing. But for example, a very simple example is WhatsApp. WhatsApp is an application that in the beginning is asking you to give access to camera, microphone, and storage, etc. And at the time you give this access, you don't give the access only for your talks, your chats on the, for example, for the microphone on WhatsApp, but WhatsApp is allowed to use your microphone full stop. And it happened to several friends of mine that they had WhatsApp with the microphone enabled, and they were talking about one topic, and just after a short while, they started to get advertisements about this topic, and that's really sort of scary, even because you can simply turn off the microphone on WhatsApp and turn it on if you need to use WhatsApp for chatting. So, but most of the people don't know it, so clearly they don't do it. And then we had other apps. One is Follow Me, that was used to show to the people the danger of having the location enabled, or even not enabled but collected by your mobile phone, because by collecting information on your on the locations that you are visiting during your day, it's very easy to profile you, for example, to understand that you are of a given religion if you visit a church or another religious building, or if your health is not perfect, if you are visiting the hospital regularly, and things like that. And then we have another application, another mobile application for interacting with the IoT devices, for having the user selected choices when interacts with the IoT devices, and another one for the smart city data collection, because even they are not considered as traditional IoT devices, even the smart city infrastructure are IoT devices that are collecting your data where you move around the city, and you use the access through some Wi-Fi in a city. So, and with this, we were already building, as I showed you, several papers and interesting discussions also with normal public, and not only with other stakeholders, I would say, and not simply with scientists. But more than this, we were able to put the basis for some really, I would say, public engagement follow-up. That was this project MAPAS, and together with that, another one that is called in Italian Indovina Automatico, that means automatic guess. And the MAPAS project that was using as target teenagers and young adults from 16 to 28 years old was built to create science education for young people, but not only for them, but also for educators and consequently also for policymakers to be very, very careful about their own data. And basically, we went to this public engagement approach for communicating with them. We created some immersive experience where we really steal them some data, and I will show you later what we do exactly, but we steal them some personal data like contacts or pictures, and we show what we can do with that. And basically and in that sense, we were, let's say, so successful that we were asked also from the organization from education in the university to create a similar experience for younger teenagers from 12 to 16. So we put together also this part within this second project, but the project is basically the same. And the project, the experience is the following. We enter in a class, we create a sort of scene within the class where we say, okay, we will come in the next weeks with you, and we will bring you a new artificial mate, sort of robot, but with really human appearance. And we have to build it together so that this new mate can stay in the classroom and be perfect with all of you. So we ask them to upload an app on their mobile phones. And on this app, we start to ask them about some very simple questions, like the picture that you see now on the screen. We ask them what type of may you prefer. So you prefer a person that likes very much to study, or to a person that is a leader, etc. And then we collect all their answers, and we go on for a very short while with this type of questions on the mobile phone. And then we tell them, okay, now you can put down your mobile phone, and we continue all together on the beamer on the screen. And we have some other questions for them that we call our standard questions, where we ask, for example, whether they what type of sport they want that this new mate will play, if he or she will like more scientific or humanistic courses, etc. Very, very simple questions that are used only to spend some time, while in the background there is a team that is, from the beginning of the story, is collecting the data from their mobile phones. So as soon as they install the app, we start collecting some information from the mobile phone, and basically we take their contacts, some pictures, not all of them clearly, something about their social, some usage data, etc. And then we build with this information some new questions that we call the custom questions, where we ask them, for example, using a picture of let's say a girl with a very fancy haircut. Oh, but do you think that your new mate will use some haircut like this one? And we put the picture. Or using some information that we find in contacts, for example, that someone has used some fancy name for recording the number of some other people of the class. Do you think that they will register Lily with the name Lily Blue, like someone else has done, and things like that? And clearly, people are, I mean, these young people are very sensitive to this fact, apart from having reaction like, oh my God, this is a very old cut hair that I used 5 years ago. I'm really horrible on this picture and things like that. But in general, as we are using some information that is personal, they become very attentive to what we are doing, and they realize what we can do with their data. And we create what we call the wow effect. And this wow effect has a very important impact on the story, because especially young people are very, I mean, they really tend to remember the things that are very wow to them. And also they try to spread this information much more. We had some people that say, oh, but now you need to go in another class because now we know the problem, but they don't know it, and you need to tell it to everybody. So we create this wow effect. And the lesson that we learn, I mean, we really got fantastic feedbacks, and we just started with this type of experiences. So we hope to continue for at least one more year, and then we will try to spread to the community tools for doing this, and to really reach any type of young people, and also to create sort of literacy to do that. But the important lesson that we learn in that story is the fact that even if we are scientists, we are ICT scientists, it's not the science we are doing is not relevant to society if we don't create the right awareness. So we can create the most fantastic tool in the world, but if this tool does not reach people, it's useless. And the best approach to reach that, to reach people, is not to be alone in this research, but to have a very interdisciplinary or cross-disciplinary team, because you have the several viewpoints and you can really go further. And it's also really important to involve all the stakeholders for that, and to have this engagement of them. And well, that's my message. I hope I have been able to pass you my enthusiasm and my feelings, because this has been really an astonishing experience, because it came from the blue for us, and we are really now building something excellent on that, and we are very proud of what we are doing. You have on this page the two projects web access. Unfortunately, at the moment, the MAPA project is only in Italian, because we are in the Italian side of Switzerland, and we are using the Italian schools for this message. But we are planning also to have translation in English of both the experience and the web page. So hope sooner we will be able to have something that is accessible to everybody. Thank you very much.
Thanks a lot, Sylvia. As I see no questions from the audience so far, maybe I can just start with mine. I think it's very interesting how you work with the young audience, and I would like to know whether there is some plan to follow up on these projects, maybe in some form of an educational program or something like that. I know that's in the future, but I would like to know if you have any plans like this.
Yes, we are doing that. We apply to have something in conjunction also with sort of technology transfer. So with the Italian radio, Swiss Italian radio, in order to involve also journalists in the story, to have educational, and I mean to have also a way to spread news to the young people. So we are building a new project in that direction, to have a literacy on the educational side for really having material for schools and for educators to create this type of education in young people, but also to get to young people from social networks and social media that are probably now one of the best way to reach them together with the school. So we are trying to reach them from all the possible, let's say, educational media that can reach them. And yes, we are doing that. I mean, as I said from the beginning, we involved education scientists, and they are very proud to do this literacy for not changing the world, but at least trying to do something better in that direction.
Very interesting. Thank you very much.
Welcome.
Okay, so I think we can move on to another speaker. Let me welcome Eneko Ajure from the Lilith project, who will introduce our last success story from CHIST-ERA.
Yeah, hello. My name is Eneko Aguirre. I'm from the IT, the Basque Center for Language Technologies in the University of the Basque Country. And I'm going to present Lilith, our project on learning to interact with humans by lifelong interactions with humans. I'll do the presentation together with Charles, and he will do the last part. Charles, they said, is from Synapse, a company in France. So Lilith was founded in the Lifelong Learning for Information Systems call, and finished a few months ago. And there are 5 partners, myself from the University of the Basque Country in Spain, also a partner from France, the LIMSI Research Institute, the University UNED from Spain, the SO University from Switzerland, and the Synapse, a company from France. So we were asked to tell about our success story and about responsible research and innovation and technological transfer. But I'll first introduce the scientific background, the objectives, and the main results that we had, followed by these challenges and exploitation issues from academia. And then Charles will introduce the last part from the point of view of the industrial partner. So, sorry, one second. So regarding the scientific background, we are all aware that dialogue systems are changing the way we access information. And as we all know, major companies are investing heavily on smart speakers. Any user who's been using this technology is aware that the current commercial technology is brittle. It's useful, but it's limited in the things that it can do. So these dialogue agents are built following predefined information flows, and they work very well for narrow tasks, like turning a radio station, a playlist, or getting traffic information, both as smart speakers, but also in cars or in the mobile. They have limited understanding capability, and the agents get confused very easily we need to be very careful on how we speak to these gadgets because they can get confused. There's only the issue that once deployed, these conversational agents need to be carefully monitored because they could run adrift, and the builders of these systems need to be sure that they are being used correctly. So this brittleness is due mainly to very costly manual rules, which are used to build these systems. As an alternative, the research community is trying supervised machine learning, where instead of building these manual rules, or in addition to building these manual rules, the task is to collect and annotate interactions, and then build a system which learns on these interactions, on these annotated interactions, to build the conversational agents. This is much more cost-effective than writing rules, but it's still a research topic because there are some issues with these kind of systems. Among those issues, one is that the quality is bound by the contents of the collected interactions. So this annotation and collection process is key for building good systems. The other issue is that for each separate domain, one is to collect these additional interactions. And it means that this is still costly to deploy in new domains. So Lilith is going to try to tackle these issues, applying lifelong learning techniques. So the key observation here is that because we are building conversational systems, user interaction is natural. I mean, we have the user at the other side of the agent, so we can seamlessly obtain feedback and information from users. And the key challenge is to use this additional supervision to improve the system for free. For free in the sense that the developers don't need to collect additional or annotate additional data. There is the advantages of reducing the size of the annotated interactions, so lowering the cost of deployment, especially in new domains. And in principle, this could allow the system to improve the quality across time, because the more it interacts with users, the more it will improve. So the scientific objectives of the project are the following. One is first to build reproducible benchmarks for evaluation. This is key in such interactive systems and is not completely a solved research issue. The other one is to apply lifelong learning to knowledge induction, to the knowledge that the agents are using. The third objective is to build a dialogue system for question answering, which in the fourth objective, we will try to improve using lifelong learning. And finally, there's the objective of having an industrial use case and chatbot. In this presentation, I'll make a short summary and I'll follow on three of the objectives. And then Charles, in his part, he will call about the industrial use case and chatbot. So the first thing is thinking about how to define lifelong learning and to build reproducible benchmarks for evaluation. So together with the other partners, together with other projects funded by the Lifelong Learning CHIST-ERA program, we define lifelong learning as learning after deployment. Here you have three charts. In the left chart, we have a regular deployment scenario, where in the red line we see a system which is trained in the premises of the company and then is deployed, and the performance of the system doesn't change with time. While a system which is able to apply lifelong learning and learn from feedback, in principle could be able to improve over time. On the right, we have a more realistic case where the system is deployed and the conditions changed. For some reason, the distribution of the dialogues that the system is encountering is going to change across time. So a regular system, the current AI system, in front of the changes, the performance would drop dramatically. The same thing would happen with a system with lifelong learning in the green line. But in this case, because it's receiving feedback from users, it could in principle recover and keep improving the performance as long as the user feedback is useful. In this sense, I wanted to mention that apart from this definition, We also produce a survey on a journal for evaluation methods for dialogue systems, and we produce 4 benchmarks. I'm going to focus on 2 of them in this talk. The first one is an evaluation method that we produced and won an outstanding paper award in one of our main conferences. And the idea here is to provide a method, a cost-effective method for evaluating chatbots, dialogue systems. So previously, these kind of systems have been or are being currently evaluated in the following manner. In the left side, we see that a human, the evaluator, is interacting with the chatbot, and then it directly ranks the quality of the chatbot. This is very costly because you need to have this human rating all the chatbots that you want to evaluate. Alternatively, we can have humans chatting with non-experts, chatting with chatbots, and then an expert which analyzes these interactions and then rates the chatbots. Our proposal is to have humans doing a different task, which is easier than ranking directly. The task would be that in front of the human, we would have dialogues between human and bots, or possibly 2 bots, and then the human needs to detect as quickly as possible as it reads through the interaction, which is the bot. In this task is very effective because the human doesn't need to be an expert, and we saw that there is a high correlation with other evaluation methods. So this way we produce a good ranking quality. I mean, we are able to detect which bots are better with a very low annotation effort. That's one of the evaluation benchmarks, and I will now introduce the other one, where we are going to focus on conversational question answering systems. In conversational question answering system, the task is that given a passage, like this one on the right in red, extracted from a web page about cooking, and then given a question in blue, the system needs to retrieve from the document a possible answer for this question. Well, in fact, we are doing conversational QA, so we have the passage, I mean the document. Then we do have previous dialogue history where we have questions and answers, and the task is that given that passage and the history and a current question, we need to find an answer in the document. So we produce a benchmark for this problem called DOCA, where we want to access domain-specific information available on FAQs via conversational QA. Why FAQs? The thing is that there is a lot of enterprise information available as FAQs, and it answers to real information needs of users. So we think that this is a very good scenario for applying conversational QA datasets. So after we built this benchmark, we wanted to check whether domain adaptation, I mean training in one domain and applying it to another domain, was more cost effective than starting from scratch. We built a state-of-the-art conversational question answering system, and then we trained the system in one domain, Wikipedia, and then we transfer it to another FAQ. And the results are very positive. We show that only with a small annotated interactions from FAQs, one can transfer from Wikipedia to FAQs effectively. But now the question is, if we are going to deploy these things, is it actually feasible to deploy these systems with no annotated interactions? So the question is it possible to profit from user feedback to minimize the amount of annotations and to get rid of new domain annotations? And this is the question that we examine in the following part. So in a traditional workflow, as I mentioned, the company annotates limited amount of training data, trains a system, and this system is deployed as is to the user, which poses question and receives an answer. Any improvements or changes in user behavior will require the company to go back and train again the system with new annotated data. In our proposed workflow, we are going to take advantage of user feedback for improving the system. So given a question and an answer, sometimes the user will give feedback saying that he didn't like the answer or that he actually thinks that the answer is correct. So we produced a research piece, which also won one outstanding paper award in one of our main conferences. We had to devise a new machine learning technique to take profit from feedback. And I have to say that we use annotated data to simulate the user feedback. We did 2 sets of experiments. In one, we trained on Wikipedia, and then we deployed the system on Wikipedia questions and answers. And in the other one, we trained the system on Wikipedia, but then when we deploy on FAQs, on a cooking FAQ, and we test how it works with other FAQs. So our results are positive, and we show that after training a system called S0 on Wikipedia and deploying it, we are able to improve the system by 10%, by 4 points, which shows that it's possible to improve systems after being deployed. But the results are even more interesting when the system is trained on Wikipedia and then we deploy it on users who are making questions about cooking, movies, and travel, where the results are even better because the improvements are around 10 points. So all in all, it shows that it is possible to learn after deployment, especially in new domains. As I mentioned about the industrial chatbot, the other main objective of the project that will be presented by Charles in a minute, I wanted also to show you some numbers. The project was very effective in producing high quality research contribution, like papers in top quality venues, also topic specific venues. I mentioned 2 outstanding paper awards. Also, we had a special session, a keynote in a New Rips Expo. And then we also produced a spin-off projects and collaborations and 3 PhDs. One of the collaborators also won 2 Google Research Awards, and we had several dissemination activities. So now I'll move on to the main topics of this day in CHIST-ERA. I'll first mention briefly something about sustainability and valorization, and then about the challenges. So as I mentioned, I'm going to focus on the academic side, and then Charles will do the industrial side. So regarding research-oriented exploitation, our model is based on open publications, open datasets and open source code, and evaluation protocols and reproducibility. The technology transfer for academics is based on this open datasets and code, and then consultancy and on-demand adaptations. So regarding commercial exploitation, Eleni, which is a subcontractor of Lindsay from France, thanks to Lily, they were able to extend the evaluation capabilities so they now can offer evaluation services for this kind of interactive systems. And they are collaborating with Confiance.ai and the French Grand Défi. Now, what is our view, or what has Lilith have to say about responsible research and innovation? So I will mention something about gender equality and then open science in a minute. About gender equality, we have to admit that we didn't reach 50% of researchers in Lilith, but some of the factors are really external. As you know, and it was mentioned before, in computer science, we do have a shortage of female computer scientists. And sometimes, for instance, we found that the PhD students in some countries are recruited by the government, so you cannot decide beforehand the gender of these PhD students, or you cannot balance the gender of these PhD students. And also in some cases, the job candidates for postdoc positions were 100% male. I also have a general comment about these issues, is that I think the most effective use of the energies, it might be at the institutional levels, and the institutions should think of how to assist and research projects in order for them to do more responsible research and innovation. Because this needs resources, and as I will mention in a minute, some overhead that needs to be covered by these institutions. Regarding open science, I already mentioned that the consortium did a clear stand, both at the publication level, where we prefer conferences with open proceedings, then open access journals or paywall journals. And we promoted also the use of open datasets and released open source software. The relation between open science and technology transfer is really good in the case of the academic partners of Lilith, because we do the research with open science and then technology transfer happens as consultancy and adaptations, as I mentioned. But there are obstacles for open science, in some cases coming from the research evaluation agencies themselves. Because when we choose a publication venue for the most impact in AI and natural language processing in particular, the conferences excel. That's where high impact publications are received. But often the research evaluation agencies tend to value closed journals more. The other issue is that publishing open datasets and software requires a substantial overhead from our researchers. And again, a researcher who spends a lot of time to clean his software for being properly used or cleaning the dataset, so it's properly used, this effort is not taken into account by the research evaluation agencies. Or if they take into account, they apply one size fits all without evaluating whether really the dataset or the software had a high impact or not. I think these are obstacles that need to be taken care of. Regarding the budget, I wanted to mention that many journals, I think they overcharge high fees, and I think this money would be better used elsewhere. Regarding technology transfer, we think Lilith was especially successful in technology transfer, and one of the keys was that Synapse, the industrial partner, was part of the project. But not only that, because it's not enough that you have an industrial partner. In our case, we were very lucky that the industrial partner involved personnel with research experience, either PhD students or PhD level personnel. And this allows for a seamless conversation in the project about scientific results and the commercial opportunities. The other key for this successful transference was open science, because this allows for the company to quickly raise the technological readiness level of whatever technology they are interested in. There are some challenges for technology transfer in CHIST-ERA. I think the challenge is that if we want future and emerging technology types of projects, which I think we do for having scientific breakthroughs, then the academic partners need to focus on those research breakthroughs for the full duration of the project, because it's not easy to obtain such breakthroughs in just 3 years with multiple partners. So this means that during the duration of the CHIST-ERA project, some exploration opportunities might be missed, and we are aware of this in Lilith. But possible solution would be, as I think we have, is to have follow-up calls from the European Innovation Council, where future and emerging technology kind of projects have additional funding to explore these exploitation opportunities. Okay, and now I'll leave the floor to Charles about the industrial partner.
Thank you, Eneko. May I share my screen, Michaela?
Yeah.
Yes. Thank you. Okay. Should go in a second. Is it fine?
Yes, all good.
Yes, thank you. Well, hello, everybody. I'm Charles Tessèdre from Synapse. I'm the scientific director of Synapse. Synapse is a French software editor that was the industrial partner in Lilith project consortium. So first, thank you, Eneko, for presenting the scientific background of the project, which made, of course, this project a real success. And I'm now going to talk about another aspect that made Lilith project a success, which is the fact that open science led to and enabled fast, effective technology transfer, and how and why it worked well. But first, I'll briefly describe my company, Synapse, which designs QA dialogue systems meant to ease access to technical documentation. So these dialogue systems rely on proprietary technology called machine reading that automatically generate potential interaction, procedures, and decision trees for dialogue management. And as for now, our main end user targets are company personnel who need to access to technical information stored in the system. So here are two examples of Synapse chatbots. One on the left is used by the French Public Bank of Investment, the other by an accountancy company. So as you can see through the example provided here, both are meant to answer domain-specific information about procedure, regulation, any technical information. So here are some examples of constraints we face when we design domain-specific chatbots for our clients. We have limited access to qualified data at the beginning of the project. This is something we cannot overcome. I'll come back to this later on. And another challenge is that we have to try and use, and that's the goal of Lilith, to use feedback to improve our chatbots after deployment. But those feedback, they can be noisy, they can be inconsistent, they can evolve over time for many reasons. And therefore, transferring Lilith's results into our technology required being able to exploit noisy feedback. So first, why is access to data such an issue? Well, for two main reasons. One is because of our company. Synapse is a non-vertical company, meaning we are not tied to any specific domain. Hence, we don't have a domain-specific data, medical sector, legal sector data, for instance. And on the other side, most of the time, our clients use data that is sensitive, protected by industrial confidentiality, or may contain personal data. So here, ethics concerns are involved. So most of the time, we never have access to our client data. We just ask for enough representative data to understand their needs, and then try and develop and design chatbots to provide access to their data. So Lily's project provided an elegant solution to that issue, designing algorithm to further train model initialized with only limited data. And this this model then can be further trained exploiting user feedback. That is how Lilith answered to an important industrial challenge. So having said that, we now face another challenge, which is the fact that user feedback can be inconsistent from a user to another, or depending on their knowledge background, or depending on many reasons. But also knowledge evolves over time. You mentioned regulations evolve over time. So what was once considered as a good answer may not be tomorrow. So what we have to be able to exploit feedback, knowing that feedback can be a very noisy material. That is the reason why we develop a model to reduce the noise in this material. So that helps us to collect and exploit noisy feedback on frequently asked questions, designing QA dialogue systems that improve fastly for recurring questions. So Lily's project was a nice example of fast, effective technology transfer, as we're on the verge of launching now into production QA systems with lifelong learning features, leveraging user feedback. But I think another great achievement of Lily's project is that post-deployment learning, leveraging user feedback, is not limited to QA dialogue systems. It's a generic approach that can be implemented in many, in many different use cases where learning algorithms are involved. For instance, so we are a language analysis provider. We provide different services. One of them is sentiment analysis. So let's say a new client comes to us with a need for a verbatim opinion analysis in human resources, trying to collect fast food employee feedback, for instance. That's happened, so that's why I'm talking about this one. We can provide them fastly with a generic model, then that can evolve over time and further adapt to their specific situation or need, thanks to this approach. So, yes. So as a conclusion, we can say that in Lily's project, technology transfer has challenged open science for the reasons I mentioned already. And in return, open science benefited the whole community, both research community, industrial partner for where I stand, and hopefully it will help designing language tools that will benefit the whole society, or the whole, at least, the people who use them. So technology transfer and open science were always closely tied in a Lilith project, and I think this is the reason of its success. And maybe finally, to conclude, I think it's important to mention that Lilith is a threefold project that tackles the scientific issue on one side, designing continuously learning algorithm. It also tackles the societal issue in a context where knowledge evolves continuously, fastly, in an asynchronous and decentralized manner. So it's important in this kind of context to design tools that can reflect this evolution. And finally, tackled some industrial challenges, which I already developed on. So working with limited qualified data, designing robust systems that can ensure user adoptions at the early stage, and then that can learn throughout time to improve. So I think the fact that this project has always been guided by these different points of view was a key for its success. So this is the end of this presentation. I don't know if Eneko, you want to add a final word, but in case not, we can directly skip to
No, that's fine, Charles. Thank you.
question session.
Okay, thank you very much, Charles and
Thank
Annika.
you.
I would like to ask, because Annika, you mentioned that in your presentation that open science allows for quickly raising the TRL, but we often hear, on the contrary, that there is some tension between open science and technology transfer, you know, especially from the point of view of the company. Maybe for you, Charles, this is relevant, where people would be worried that, you know, your technology gets stolen or things like this. So if you could maybe elaborate on that, if you had any problems with this.
This is something I've not been developing here, but I think it's important to understand that we are at Synapse a small company with, as I said, have limited access to data, to our client data. And also open science moves really fast and bring new algorithm all the time. So for us, we are less and less trying to develop inside our company a new algorithm. For this, we trust open science to bring new algorithm, and we don't have access to data. So where do we stand there? So it's important for us to design tools that helps collecting data, that helps switching algorithm, and that brings new user interface that can collect interaction and make the best use of this interaction to improve the models that are used behind. So this is where I think all this is tied up in a meaningful process where open science can benefit companies and helps designing tools to help to retrieve information.
Yeah,
maybe Eneko, you want to? Yeah,
I can maybe add something else. Is that the open science allows the technological partners and academic partners to produce prototypes much faster than if they had to build them from scratch. So the question answering system that I presented is built over models that have been released by Facebook, in this case, the Facebook AI Research Center. So that allows us to build really strong systems quickly. And then the companies can make use of that software or build their own, but at least they know where they are standing. And also that regarding the coding, and then regarding the data sets, open data sets are key because otherwise companies don't know if their system is working properly or not. So they can very easily compare to the state of the art that research is producing. So I think that those two are keys.
Okay,
Key
thanks
elements.
a lot. So yeah, with this we can conclude the first part on the success stories. Let me just share my screen now. So now we can move to the break, and I will just give you a few instructions for this because I would like to encourage all of you to join us at the Wonder platform for the networking. You can of course use this break for your own time, but it would be great if you could join your colleagues there, maybe with a cup of coffee. So it's actually very easy to go there. So in the comments, you will in a short moment see a link for the networking platform. and the password as well. And so once you click on the link, the page will open and you will have to answer an icebreaker question. And the answer will be visible to all of the other participants in the room. And once you're inside the room, all you have to do is move around by clicking and holding your mouse. And if you move closer to another participant, a circle will be created and you can video chat in this circle with your colleagues. And in the room, you will see different thematic areas that we have created for you. And in these thematic areas, you can just move around and discuss those different topics that you are interested in. So, and also just a warning for you, you can only use your camera and microphone at one of those platforms. So make sure you turn it off at Wonder before entering Zoom. And also for your information, the room is open nonstop, so you can use it all the time during the seminar, not just for the dedicated time slots. And it's also open even when the host is not present. So we can now move to the break, and I hope I see you at Wonder, and otherwise we'll reconvene here at 3:20. Thank you, everyone. Okay, so welcome back, everyone. I hope you had a nice coffee break and that you're well refreshed for the rest of our program today. So now we can start with the second part of our day. The first speaker will be Jan Kleindienst from CHIST-ERA, but also working in AI company Mama AI, and he will present a speech on technology transfer challenges. So the floor is yours.
Thank you. Let me just find my slides in a moment. So I'll share the desktop. I hope you can see it now.
Perfect.
Okay, let me just start it. Very well. So thank you very much for inviting me. It's great to be here and talk to such a wide audience of folks. The organizers asked me to share my point of view on the topic of technology transfer, given my 30 years of experience in working at international R&D. My name is Jan Kleindienst. Most of my career I've been working at IBM R&D. And early this year, I have co-founded a new company called the Mama AI, which has become an IBM business partner. And I'm delighted to share my experience with those years of working on the side of research and on the side of development, and also with the pleasures and pains of founding a new company in this very innovative environment. So on the agenda side, I will explain where I'm coming from so you understand my perspective. That will allow you to calibrate my comments properly, because naturally everybody comes from different backgrounds and brings some biases into the discussion. And I will also talk about both sides of the technology transfer equation as in the analogy of the bridge, where the bridge connects the ideas and inventions on one side and the innovative products on the other side. And to describe it, I choose to create two personas. Sylvia, the scientist, that is the one that produces the ideas and technology, and Barbara, the businesswoman that attempts to commercialize whatever Sylvia has invented. So we'll talk about that, and we reserve enough time for Q&A, but please do feel free to ask questions during my talk or save them to the Q&A session, up to you. I'll be happy to answer them in either case. So about me, I've been joining IBM in early 90s at the TJ Watson Research Center in New York as a PhD student. And, they spent 2 beautiful years in the US and then returned back to the Czech Academy of Sciences to continue working on my PhD in theoretical computer systems or theoretical computer science. Then I rejoined IBM Research in Czech Republic because IBM was kind enough to open a lab in the Czech Republic in 1995. I joined the lab in 1997 and worked with the team on various interesting projects of applying speech recognition and conversational technologies into various environments, including cars and home appliances and others. And it was being part of the FP5, 6, and 7 projects. We also worked on some DARPA projects. So there's been a lot of interest in technology transfer and how to do the transfer properly and effectively and efficiently. And then when the Watson technology came out and IBM won this Jeopardy challenge, we've been asked to commercialize Watson internally at IBM and make it a product. So my team has been asked to join almost like a startup within IBM called Watson Group, where we started to work on commercialization of the Watson NLP technologies into more marketable and sellable software. So, 13 years I actually worked in the role of being a director of the local Prague Watson AI Lab. And as I said, at the beginning of the year, we have co-founded a new European startup where we will continue working on the conversational AI and other similar technologies. And I happen to be also part of the scientific board at the very Czech Technology Agency of the Czech Republic, where I am more of the guardian of the AI direction of the research and applied science. So just for fun, to bottom right is my badge or my page from the IBM Live, and on the bottom left is the fresh one on the LinkedIn for the new company. And in the new company, we pretty much continue working in the directions we have been doing at IBM, where we work on the conversational artificial intelligence, namely assistants and chatbots designed both for voice and text. We also work on speech recognition, or with the speech recognition, to provide call center transcriptions, log analysis, and other things. We do have a brand or section of working on the applied AI for various kind of signals and models built on those signals, and all that wrapped in all kinds of different business environments, including cloud and edge, IoT and hybrid environments. And since we're talking about the man-machine interactions, and the name MAMA actually also means man and machine, we are caring about research of the new kinds of interactions between man and machine. And at the same time, to conclude, we also generate data or text based on structured data. So we do have that, not only the understanding part, but we also do have the part that produces that produces text that could be readable by a human being. So all that is very interesting frontier for doing technology transfer from our research team or from academia and our partners at the universities. And there's lots of best practices still to learn and practice. So before we just talk further, I think it's worth to just remind ourselves what the technology transfer really is. and it's really something like an invention, a science, a piece of technology developed by a few bright minds that can be transferred into products and processes, applications, materials, or services used by many of us. Right? And how we do it, we share skills, we share knowledge, we share technologies, manufacturing, method samples, and facilities with the party that is receiving the know-how. For the sake of this talk, I will be focusing mainly on the machine learning, deep learning, and AI domain, which is where I've been playing all my career. I will not cover things like material science, life science, or biotech. So now it's when I'm explaining technological transfer, I often use this concept of a bridge, right? It's very it's pretty descriptive because it connects to landscape. You can view it as a landscape of the land of science on one hand, or one end, and the land of commerce on the other. And so you bring the innovative technology to the users and customers in the form of a replicable and scalable product that lives on that land of commerce. And clearly, the bridge is not just unidirectional. It doesn't just go from the land of science and research to the land of commerce and development. It's much more than that. The traffic actually flows in both directions. The ideas and algorithms and technology and solutions go one direction, and data and customer needs, improvements, ideas, metrics, benchmarks, best practices, it travels back, and they meet at the bridge, and they can interfere with each other. And there are also different lanes on the bridge. The different vehicles travel on the bridge. They're running at a different speed. Maybe the vehicles, they have different expectations. They also often goes from one climate to a different climate, or from one culture to a different culture. And there are also different rules and laws apply on each of those lands. And the inhabitants sometimes speak completely different languages, or may speak different languages in terms of business and scientific jargon. So it's also, I think, worth to realize that the bridge itself, the technological transfer bridge, needs its own maintenance, and once in a while it needs good refurbishing. So it's architected well and provides value. And there could be different kinds of technology transfer bridges built depending on the speed and maturity of the technology and the invention. And talking about the maturity, this is all known to us, and especially to you, ladies and gentlemen, working on the Horizon 2020, right, those technology readiness levels that the European Union adopted from the NSA. It talks about the basic principles and the maturity of the technology at the 9 different steps and degrees, where one is the very basic that progresses over technology being developed, validated initially as a concept, then in the lab, then in a relevant environment, and then the technology is turned into a system that is being demonstrated at under certain operational parameters. And then at the readiness level 8 and 9, when the system is complete and qualified, can progress to the actual system that could be commercialized, or could be commercialized properly. There's some discussion about these, as you know. So some stakeholders claim that this is too narrow, and that this innovation chain captured by or used in Horizon 2020 doesn't really match the non-linear development of the research domains, and there are some alternative schemes being proposed. One talks about several dimensions. So one says you should actually talk about more like a scientific readiness, and then the customer readiness, and then the market readiness, and perhaps the society readiness. And and innovation readiness. But I think it's good that some of these steps are defined, and it clearly tells the distance of the particular piece of technology from its maturity and what kind of treatment it could be used for that given readiness level, what kind of bridge could be used to transfer it to the land of commerce or to the land of development. And at the same time, there are some dictums, if not almost axioms, that talk about the path of invention to a product is difficult, and the technology value is typically not easily convertible to business value because there are lots of challenges along the way. And the cliche that startup is a search engine to find and implement the right business model. And it is true, right? All that these have in common is that you need to, on the land of commerce, you need to find some compelling value hypothesis why customers would use your innovative product. And companies typically go through many iterations before finding the product market fit for that piece of technology. And you also need a luck, serendipity, and lots of muscles in the process. And you need to have a good team and good market to increase the chances. And only then you reach the moment when a startup is finally ready to serve a widespread set of customers that resonates well with the product. And when you talk to people at the different side of the bridge, you discover that most of them typically don't see the other side, or at least don't see it that clearly. When I was a researcher, I had little idea of what commercialization of technology really means, and what challenges it involves. I mean, to me, it was clear, hey, we had a great idea of speech recognition product, so why is it so difficult to put it on the market, right? And then only when you're getting more experience, you realize all kinds of hurdles that you need to face to put the technology out there. So let me just go and let's talk a little bit about each side of the bridge in very concise form, but let's model the concise form in terms of a personas, right? And it's sort of a typical inhabitant of that land. So let me just introduce Sylvia as the scientist that lives in the land of science, right? Sylvia starts with S as a scientist so that it's easily remembered. So, she cares about what I did as I was a PhD student and did my my research. She wants to have an interesting PhD topic. It's a good publication potential. She needs to worry about what's the state of the art. Is there any key idea I could use or I can think of? I'm shooting for a moonshot, or I'm doing a roof shot. What is the impact on science my research will have? Right? What ethics and responsibility I need to be aware of, and how it resonates with my internal values. What is the team I will work in, and what are the chances that we make it? What practical sense, what is the experimental setup that I will be working on? Maybe she needs to train a bunch of models, right? She needs to have a good data, representative data. She needs to have access to a good training hardware to be able to make progress and don't wait or waste weeks or months in training and repeating the experiments. She needs to have a good set of test data and development data to make her tuning work properly. She needs to care about robustness, because when she's publishing the paper, or she would be offering that to some other users, she needs to make sure that the model operates well under different conditions. She needs to worry about benchmarks and evaluations, and maybe she participates in regular evaluations to prove that her idea and her technology works the best. She also needs to figure out a way how to license this technology if she wants to proliferate it. And she's lucky to, have access to what I didn't have 20, 30 years ago, which is the open science community and movement and ideas. So that's the Sylvia that lives in the land of science, right? And then there's Barbara as a businesswoman, starts with B as a business. She has a difficult job now. She takes what Sylvia produces, and now she needs to figure out her piece to make sure she turns what Sylvia has created into a commercial application or a commercial product. So she needs to find that product market fit. Right? She needs to figure out how do I actually fund it? I mean, is it a pre-seed kind of investment? Is it a seed? Should I go ask some VCs or there's some private equity involved? She needs to worry about the time factor, because every step she makes, it starts burning cash, it starts burning man days. She needs to figure out what's the time to market, how fast I can turn that technology into something that people would use, what kind of skills I need. Do I have a skill match? Is there someone who can transfer that directly from Sylvia into my team, or do I need to do onboarding and ramping up of those skills? Should I include a pilot in the process, and in what way, how I set it up? What's the duration of the pilot? And I need to find very soon if there is a potential in what Sylvia has produced. So I need to fail fast in the process. And if I progress further, I need to worry about the maintenance and support. Will Sylvia provide me L2 or L3 support on the product, or do I need to hire someone and train him to do so? Right? On the side of the consumers, how much do I understand what consumers and what my consumers actually want? What are their classes? What are the personas? Am I selling this as a B2C, business to customers, or as a B2B? And if it's business to business, then do I go sell it to the CXOs level, or the line of business, or IT department? How do I analyze my market? What kind of analytics I can use? Do I have user studies design? Do I have focus groups? What do I do specifically about marketing? What is my selling strategy? How should I figure out the pricing? What are the key KPIs that I will be able to tell to the customers? And what are the metrics on which I'll be measured and paid? What is my funnel? I mean, how much customers I lose along the way from advertising to really accepting? What kind of value I can offer to the customers in terms of progression? What is my value ladder? Right? What are the modules that Sylvia has invented? Can this be made incremental so that I can reduce my risk and go from one value to higher value? Should I figure out this as a product which I sell routinely, or should this be more like an offering, which is some kind of a value-based product which has additional things around it? I need to find the right value. And now the legal department comes in. I mean, what kind of contracts we should write? Is Sylvia being careful enough to provide enough of the certificate of originality of that invention? I need to figure out the licenses. Is it IP protected, or do I need to protect it? Are there trademarks involved? What other kind of investment protection I need to do? Now, what if it flies, and what if people use it, or what if some companies use it? What are my liabilities if I'm making a video recognition software that checks some products on the line and on the market floor? What if this thing fails? What liabilities will go after my company? Right? I don't want to break the level of trust and compliance I have with my clients or with the regulators. I need to worry about the ethics of the business I'm doing and my corporate responsibility. And then also, I mean, to be successful, I need to look at the competition. What are they doing? Are they doing something similar? What is my differentiation based on what Sylvia has developed in terms of differentiating to competitors and partners? Partners are another story. I mean, are there any synergies on the market I can use to partner with people to make this product more accelerated on the market? And regulations, another set of stories, not only GDPR with the data controls and processors, but other sort of regulations in collecting and using data for the training or derivatives of the data for the training. And then if everything goes well and the product is very successful, then what is the service level agreements if I make it as a service? Like what kind of reliability I should have on the product if my service goes down, how, if it's not a service, if it's a piece of product, how do I embed it in some existing environments? Many customers have their existing environment, so I need to figure out embeddability and how to integrate it in the existing backends or legacy backends. And if it really grows, hey, that's great. So how do I scale it? It's fine if 50 users actually calls my product. If 5,000 users call my product, but how about 5 million users use and call my product? And what is my high availability schema or algorithms to make sure that I do have enough resilience, right? And then a bunch of other things like you need to have a contact center or help desk if you want to support a product, and ideally have some kind of league of tech evangelists that would talk about the product and build a community. And everybody now in the industry is fascinated by the keyword of zero code customization. They would expect that you take whatever piece of nice innovative product and you could throw it in on the business side of things, on that business side of the bridge, and there would be zero code customization needed. So you don't need to have programmers or PhDs that would customize your piece. There would be some tooling, easy enough tooling that your line of business or you as a customer can customize it based on your needs, right? And then this is all what Barbara needs to worry about. And then also the last thing I mentioned is how much she wants to be focused or defocused in her product portfolio. And I give you an example from where I'm coming from. Like we in the company in IBM and the new company, what we do is a conversational AI that has a widespread of usage. So it can answer questions about things. It can educate you. It can solicit information. It can guide you through various business processes. It can handle transactions, and both reactive, you call into it, you call into this voice assistant, or proactive, it calls you out and tells you some kind of information. Also, it could be a client facing. So it talks to your clients. If you are a bank, then that voice assistant may talk to your clients and do things on behalf of the bank, or it can talk to your agents inside the bank to give them some additional internal information. And this is all across many, many industries and domains, right? So you need to be able, as a Barbara, to figure out, I'm with this innovation, am I going for all kinds of directions, or I'm focusing on several ones, and why am I focusing, and what kind of role the Sylvia's invention play in this thinking process. So that's that's about the worries that Barbara has and that she needs to share with Sylvia, so both have a good understanding. And also, as we're living in the world of data and machine learning, right, there's this life cycle of, and several of you have mentioned that already when I heard the initial part of this conference, where you have a bunch of data in the process that are coming from all kinds of different sources that Sylvia would love to use, Barbara would love to use, but they're unable to use them both at the same time. So you need to figure out a way how to let some data to be used by by Sylvia, which are typically a public access data. So this is the yellow bunch of yellow rectangles where Sylvia can do her cleaning and data selection and analysis, and then model training and model tuning, and maybe create some kind of pre-trained models that are available as an open source or open models. And then what Barbara needs for her clients, she can grab those pre-existing models and do some private data collection, or use that pre-existing models for the clients, and then does the transfer learning for them, including the model mixture and model tuning. and finally just going into production with the model deployment and model maintenance. And all that needs to be governed through a data governance. You need to understand where the data are coming from, how reliable they are, what are the important metadata on that, how much you trust the data, how frequent the data change. So it's always good for both Sylvia and Barbara to understand for their particular task what is the life cycle and what parameters it has. And one of the, I'm getting to the end, but one of the things that I want to discuss here is, especially for Barbara, but Sylvia should be able to take benefit of these as well. It's called elements of value. So there's a concept of, if you want to make your product successful, it has to have a set of values. And the more values you can tick in this pyramid, the more successful probably your product will be. And there are different perceptions of different kinds of demographic groups in what values they prefer. But typically the pyramid starts from the very functional set of values, like it saves you time, it simplifies, it makes you money, it reduces the cost, it reduces the effort, goes to more emotional levels. It reduces anxiety, rewards you, it gives you some sense of nostalgia, it has some therapeutic value, fun, entertainment. And then it goes even higher, which is it gives you some kind of motivation, extra motivation, gives you a hope, gives you a sense of actualization, of achievement. And the top level is more transformational. It makes you, changes you, right? And when you're doing a research or when you're doing the commercialization, it's a good practice to understand what value your product or invention or innovation is attaining in this set of products. It's coming from the Bain and Company, was being recently introduced. It's a very good collection of product. And if these guys checked Apple products, for example, then they discovered that 11 out of those 30 lights up for the Apple products. So you don't need to obviously cover all of them in your product. I think a few is good, but it's good to understand what those values are when you're doing your innovations and inventions and building innovative products. And last slide before I conclude, on the open science, I know there's a speaker after me that covers that topic completely. So I just want to say that I think open science is a great thing. It's absolutely perfect for academia and companies to have some, quote, common fountain of knowledge where they can share things, or more like academia can share things and business can get great ideas and occasionally also contribute, or there are even businesses that contribute on the primary basis to the open source software and open data and open access publication. And because of that, there's been a tremendous progress, and we have been able to accelerate the technology, especially around the artificial intelligence and sharing the data and benchmark and pre-built models on the exponential basis. So, as a summary, I think the technology transfer is an essential piece of the innovation process. It's an inevitable part. It needs to happen. You need to go across that bridge. The road is difficult, but everybody, to make progress, we need to travel that road, and we need to understand the difficulties associated with turning the technology value into a business value. And I think the good news is you guys already experience it in your own research and technology transfer processes. There is a probability of success that can be increased. And I believe it can be increased by both parts of that bridge. Understand the business needs and practices and constraints on one hand, or especially on the side of the scientific land, and also understand the technology incremental, that technology needs to be incremental, configurable, and embeddable. Also on the side of the science land, and both of these, Sylvia and Barbara, they really need to care about the value, how you specify the value and the impact. And also, it's important to treat the architecture, the life cycle, and regulations as those key ingredients, especially in the area of machine learning and deep learning, for any viable business model. And last but not least, the open source and data and publications are excellent drivers of the progress in this field. So thanks for your attention. I'm open to any questions.
Thank you very much. From my side, I think it's very interesting presenting those two different point of view of both Barbara and Sylvia. And I think that an interesting question would be to see what is the reason, or how can it be resolved that it seems that sometimes both Sylvia and Barbara speak kind of different languages. You know, it's a broad question, and I know it's probably hard to pinpoint, but if you could say whether there are some reasons that you see specifically from your experience.
Yeah, so my experience has been easy because I have been both Barbara and Sylvia. Right? I've worked as the research scientist, producing innovations, and I've worked as the development manager, actually accepting innovations and turning them into the product. So I think what we've done in my previous career is sometimes it's good to do some kind of rotation, or at least to have exposure where Sylvia could be part of the Barbara's team for, I don't know, a summer, and vice versa, because that brings those two speaking nations together. You realize that they are human beings the same way you are. They have their own set of desires and enthusiasms and ambitions to be successful with the product or with the innovation. So you basically understand that you share the same goals, even though it's articulated in a different languages or taxonomies or paradigms. So I think the closer we can bring Barbara and Sylvia, at least for some time of weeks or month, the better it would be in making the transfer of technology across that bridge more efficient and impactful.
Thank you. Great conclusion. Okay, so thank you very much. And I think now we can give the floor to the next speaker, which would be Ahmad from SNSF, who will give us a presentation on the different challenges in open science.
Thank you, Michaela. I'm just waiting for, yes, the opportunity to share my screen. So good afternoon, everyone. And thank you very much, Michaela, for this lovely organization. And first of all, thanks for all the participants, and particularly for all the speakers this afternoon, because they made my life very easy. I think open science was touched upon clearly through all the sessions, and with many interesting concrete challenges. Jan just mentioned now that I will cover completely open science. That would be very optimistic given the time that is allowed. I think it's a quite broad topic with many challenges, but I try to touch upon some interesting challenges that I think are relevant today. So I'll first of all quickly, I think, motivate open science and define what open science, what open is for science, and then talk quickly about where we stand today, what are some of the current practices, policies, and what is needed, what's going on today, and what are the challenges, and how could we tackle them all together. So this is not a complete overview of the field. It would be too reductive to cover it in a short time. Neither it is a historical overview. I'll present some general personal reflections that are inspired from various sources, discussions, readings, and personal views that I have. And especially, it's a quite fast-moving field, so it might be that the status by the end of the talk is already quite different. So why open science and what are we talking about? I like to think of science as a universal institution where, or as a field where different people grow different crops and they try to see what they get and analyze and then get the benefits of that to the society. Um, it is characterized by many characteristics. It is universal. Usually, researchers do science, or people in general do science without particular interests, mainly driven by passion. And there's, of course, always the communities around questioning, raising questions, really to reach the truth out of the research that we're doing. And when we think about all those characteristics, I can at least personally not but think about open science. Essentially, these are concepts that are also driven through at least the modern definition of open science. So in a sense, science is open by nature, and it at least must be. Why is it important? Uh, Obviously, it increased transparency, and it helps reproducing scientific works by giving openly all the sources and of the work that we've done, generally to the public without any barriers. And given that there are no barriers, works are more visible. So that's also a big benefit for researchers themselves. And in particular, it avoids also, when we talk about research funded by public funds, also duplicating or even triplicating payments of the same research. When one has to pay to access, for example, when you're talking about publications or data, when one has to pay to access, to publish a paper or to access it or even to reuse it, those are, again, always the same research. One could think of that open science could be in clash perhaps with intellectual property or some clauses or some confidentiality. But on the other hand, it's a very important ingredient for technology transfer. I think that was clearly mentioned today. It is a driver of technology transfer, in particular for small companies and startups who do not always have access to big resources and data, and particularly when we're talking about ICT, which is why we're gathering today. So open science in general is a way to putting words on what characterizes science itself, on those natural principles that make science really a public good. Uh, it is uh, it is displayed at different levels, obviously, at level of practices, at levels of policies, evaluation of science, but even also infrastructure and any other measures that accompany those new regulations and measures. So what are those practices? What is the status today? So uh, good scientific practice is obviously not new. I think researchers have been applying um, at least some good practices in different disciplines in ICT, but also in physics, where I come from. Perhaps I should have said also some words about myself. I have a background in theoretical physics. I have done a lot of research in that area before joining the funding agency, the Swiss National Science Foundation. And in CHIST-ERA, I represent the SNSF and I lead the open science team. So even so in ICT or in physics, where I've worked also for quite some time, open science, good practices are already present. But today it's more becoming institutionalized with a set of regulations, but also measures and opportunities that that researchers can use. Um, but this is not, of course, not that obvious. There's a big gap between setting regulations and having standard practices across borders and across communities. And here CHIST-ERA plays a particular role, obviously at our level, and each one of us actually plays a role in this big puzzle. So in CHIST-ERA, that's just an example. We've put together a multilateral open science policy, which was something quite pioneering that went beyond national practices, but essentially inspired from the good national practices in Europe in particular. So we ask obviously projects to share, at least from now on, to share their publications and data openly, given the fair data principles. But also we provide support to projects for a proper implementation. And as I said, the big problem is, of course, how to scale up those good practices. It's not something that easy to make them optimal really across borders. And when I talk about borders, not just geographical, but also across disciplines. Deeper is the problem actually of cultural change. It is really to me that's a deeper problem, and this is why it's a more difficult problem than just about reinforcing policies. The basic ingredient is really to be aware of the importance of open science in our own practices. So being aware is in particular freeing ourselves from all the biases that have been accompanying us throughout the past decades, in particular in evaluation practices and criteria, in any unconscious biases that we may have in evaluating and assessing research. But this also brings, at the same time, some additional burdens for researcher that could be seen as burdens, obviously. There's need for supporting measures, for infrastructures. So all of this, all this big change does not happen in a second, just with a policy. It requires a bunch of measures and a bunch of changes at the level of the different stakeholders. And for this, it needs time. It needs the involvement of all the stakeholders. And for example, DORA is the principles of the DORA Declaration is also a particular important ingredient in driving this cultural change for research assessment. So I'll go a bit more into detail in some of those aspects, and perhaps say a few words about how one could go forward from those challenges. So what is actually preventing us from going beyond the current practices, and what all of us can do for this? So let's say from the point of view of the research practices, let's take the point of view of the researcher. I have nice results that I want to publish. How can I make my work good, a public good for the society? It's not just about publishing my work itself, but it's about also the curation of the work of the publication itself. If I want to make it accessible for everyone, I have to do an additional work. Typical examples, avoiding jargon or very specialized language. So it really starts from the way we look at our own research and how do we want to make it accessible to a larger or a wider public. Then, of course, there are, I think, sometimes some misunderstanding or at least some vague interpretations of some basic open science principles. Open science doesn't mean that it's not in contradiction with the academic freedom. It does not mean that research should be driven by what the society thinks is good. I think it's the same image of the crops that I've given in the beginning, but that's one typical aspect that one could debate on. But it's not obviously not in contradiction. It's a complex interaction between the society and the research, and academic freedom should of course stay at the core of the principles. And this is where perhaps sometimes some of the core principles of open science could be formulated in a clearer way, and perhaps some discussion here and debate is still needed. at the level of CHIST-ERA, what we do is to keep communicating on what we're doing on our own policy, and actively interact with researchers. But because what we want is at the end of the day to make open science an opportunity rather than a burden. And this is where also we try to involve as much as possible researchers in the establishment and the discussion of the different measures and policies that we put within CHIST-ERA. Then we go to research assessment. That researcher, that persona, is going to apply for funding. And obviously we all have biases. We have to be aware of this. And it's very hard, but it's important to try to free ourselves from those biases. And one of the biases obviously is related to journals, which are apparently still valued in research evaluation. And this was again mentioned this morning by one of the success stories. This is very important. One has to free oneself from those evaluation, and it goes through training. It goes through, first of all, through awareness, through regulations, but also through training. Now, another problem is, of course, related to the practices themselves. When we require data to be open, this implies, of course, burdens and further efforts to the researchers. And this effort must be properly evaluated and rewarded. If this requires a lot of time, we know that this is not just a wasted time, it's good for science, but it must be also taken into account within the evaluation itself. It's because it's not just about, again, sharing some piece of code or algorithm, but it's really setting a full documentation with any useful files that or data that are necessary to make this data useful for everyone. What we do at our level in CHIST-ERA is to reinforce the principles of the DORA declaration within our evaluation processes. This is very important. This is part of the guidelines, evaluation guidelines. We've signed the DORA declaration recently, but also we again evaluate explicitly the open science practices in projects, and this has taken a bit more and more importance, and they are now fully and explicitly part of the evaluation criteria. Those are, of course, examples, but again, the basic ingredient is really awareness and freeing oneself from those unconscious biases. This is very important, in particular for early career researchers who might be, okay, well, if I want to do good practices, but I don't want to jeopardize my career. Now, what happens at the level of the policies as well? There are also challenges. Let me take the example of the Plan S, which dates back, I think, to 2016, if I'm not mistaken. Once it was published, scientists raised lots of fears about the Plan S itself. What about the freedom of publication venue? What about the negative implication on evaluation? And this, I think, it's an image of some lack sometimes of coordination or involvement of all the stakeholders in policymaking. In particular for open science, I think it's very important to involve all stakeholders, and the researchers have to really be at the center of this policymaking. There should not be really a gap between the policies and the ones who are concerned directly by the policies. And this is how we could reduce this gap and how we could make this transition more fluid. Another example is data management plans. They can be seen obviously as highly bureaucratic. And this is where, again, exchange with researchers can help a bit overcome this burden. How? Well, if the DMP is really properly designed for particular research communities, then that might decrease a bit that bureaucratic or that administrative burden. There's also, of course, an effort that is needed from the researchers themselves. There's a change, and everyone has to somehow surf on the wave to drive this change. And change doesn't come without any costs, obviously. So there's an effort that is needed from all the stakeholders. And once this transitionary period is over, then one could settle and have a bit less burden when one is obviously used to new practices. But training is also important. Training of researchers, and in particular training of data stewards for whether researchers or even people at research institutions. This is of course part, because data curation, as I said before, is something very important. It's not just about pumping the data, putting them somewhere on some repository, but it's really to provide a big package that can be useful for everyone. And this is what we strive also to do in CHIST-ERA, to provide training for researchers, but also for ourselves to know how we should deal and with all those concepts. We actively collaborate with researchers. We have an advisory board made of people representing several stakeholders, but in particular made of people that are active researchers, or at least that have a background in research in ICT, which is relevant for CHIST-ERA. But also we interact through this project seminar. I think this is an excellent opportunity for CHIST-ERA, and not just for the researchers, but also for us to learn about what are the fears, the challenges, and how we could learn and fruitfully exchange together. So again, there's a cultural change that is ongoing. There's patience and time is needed from everyone for that cultural change to be implemented, but also synergies between all the stakeholders. It's not about some people sitting in some office in Brussels, dictating some rules and then everyone has to apply it, but it's about really a big collaboration between all the stakeholders. This is perhaps not necessarily the way things are going, but I think that's probably the way things should go. So there's a need for a collective effort. And we're almost there, but there's still a lot that we can do. So today, I think we are talking to an ICT community. We agree that we could define ourselves now in a new industrial revolution, in what is now usually commonly called the fourth industrial revolution. There's an exponential growth with the use of data, artificial intelligence, and quantum, and with the link to biological and physical systems, etc. This fourth industrial revolution, which is quite different from the ones that came before in this exponential growth and this speed. And this obviously comes with a danger, in particular for open science. One could think that some of the dangers are related to such an exponential growth of more profit-oriented market, perhaps, or somehow more privatized science. And this is why, in this context, it is very important to try to anticipate the implications of this change, of this industrial revolution, by perhaps reinforcing the regulations and supporting of the good practices, by implementing appropriate policy measures. So policy measures in terms of obviously open science, in terms of more generally responsible research and innovation. And this is very important, I think, to accommodate any potential dangers that this revolution might bring. But again, the basic, I think, ingredient is awareness and responsibility, because at the end, researchers, I think you are the main actors driving this change through the good practices, through the examples, through taking those regulations and adapting them, and exchanging with all the other stakeholders in this game, funders, policymakers, but even also publishers. So again, there's a lot of effort required from everyone. We're going through an interesting change where each one of us is an important piece of the puzzle, and we should really seek to use those synergies actively to try to achieve this cultural change that will bring the good principle of open science on the scene. So thank you very much, and I'm happy to take any open questions.
Thank you very much, Ahmed. Okay, so I know quite well what is happening in open science and CHIST-ERA, since I'm also a member of the working group. But maybe I would like to ask, as you said, that researchers should be at the center of the policies of open science. Whether you have some tips, maybe from SNSF, how to include them, how to make them heard, because in SNSF it's you are also quite advanced in those policies, and maybe you have some special mechanisms for that, or some nice experience.
Right. Well, there are good practices, and there are good practices that are ongoing, or good practices that also could be. No one is perfect, obviously. But one example is for open access. There are open access ambassadors in Switzerland who are essentially who are in close interaction with people involved in open access. So open access officer, let's say, at the SNSF. And those are researchers at, or at least people working at academic institutions and universities in Switzerland. So this interaction obviously is twofold. So they bring in the institutions all the new measures and all the contents of the new measure, but they also interact with the SNSF, who is putting also, at least participating in putting together open access, the open access policy. So that's one way of achieving such interaction. Another example from CHIST-ERA is the advisory board. So we have advisory boards for the CHIST-ERA, normal CHIST-ERA, let's say, processes, but also for open science. And this is also where one could think of the advisory board as also some type of ambassadors for open science. But I think it's there's one can do a lot more than this, definitely. But because I think that's a problem that is really I feel concerned about this, because I feel there's this gap always between policy and researchers, and I had a lot of discussions in the past with researchers in Switzerland and also abroad, and it's many people come and say, okay, come on, there are some people, guys in Brussels, just telling us what to do. We know what to do. We know what are the good practices. So there's a gap, and sometimes it's just a question of communication. Sometimes it's just a misunderstanding. But it's important to put all the people together and join forces to reach the best solutions, which have to come, I believe, from the researchers themselves.
Yeah. Thank you. Yeah, I think it's a very nice conclusion to this whole day, because it's basically what this was all about. We were really trying to connect all the pieces of the puzzle and all those different realms to communicate and understand what each other wants from them and how they can support them. So this is a very nice message for the end of the day. And yeah, so now before we go to the networking part, I will now give the floor to my colleague Florence again, who will present some information about the CHIST-ERA video contest and how it's all going to work.
May I make a comment?
Yes, sure, go ahead.
Because you didn't, okay. First of all, I want to introduce myself. I'm Maurizio Migliaccio from Italy. I'm an engineer, and I guess I followed with attention the open science part, but I guess something new happened, and we must take into account. Because of course, if you think about science in let me say, very long-term application perspective as the physics, this may sound natural, but we have undergoing experiments. The pharmacy, the big pharma experiment we are doing now, a lot of public support by European Union. And of course, since there is a very, very relevant and let me say, economic value products, there is a lot of problem if you want to put on the open science perspective, as you know, in terms of patents or whatever. So I guess Europe itself, I agree with the open science, don't misunderstand myself, but the point is that it was applied only on long-term results. Let me say, if you think about, let me say, physics, you're thinking something that may be of practical interest, and let me be optimistic, 10 years, okay, something like that. If you think about engineer, so we don't talk about big pharma, okay? We are not talking about 10 years. We are talking few years, 1 year, 6 months, okay? So the open science problem is much more intricate and probably must be revisited in view of the experience we are doing now. Because of course, what you are doing now as Europe, not myself, is funding, let me say, public research, okay? And in Europe, most of the research is supported by public funding, which is not bad. I'm not saying against this. And of course,
I think Maurizio has frozen.
Yeah, I think so too, but I'm not sure if Ahmed did.
I heard, but then I think he's cut.
Yeah,
Um,
maybe he will get back in a while, but
exactly. Yeah, I mean it's unfortunately we did not. Yeah, maybe he's probably disconnected. Yeah, that's a very important. Perhaps I could also mention complementarily in general in medical sciences. That's again related to the importance of open science in that area. There are examples where medicines were produced and were based on falsified data or experiments because they were driven more by economic interest or profit, and that was discovered later on. And you know, there's a number of examples of wrong papers, you know, published in excellent venues, and here obviously open science would play an important role in introducing an additional let's say layer of evaluation and checks that would allow such things not to happen, especially in the medical field. When you imagine you have a medicine that people are buying to cure a particular disease, then at the end it ends up having a number of hundreds of casualties, then it becomes really a serious problem. It's not just an ethical problem, an ethical pure ethical scientific problem, but it touches people directly. Yeah. Um, I don't know if Mauricio is back or.
yeah, it doesn't look like it. So I suggest we just move on. Yeah, we have Florence raising
Yeah.
her hand.
No, because I think the point of Mauricio is that the way you view open science is for long-term type of research. And how does open science... Maurizio is back, so I will let him finish his point, but he needs to unmute.
Okay, Mauricio, are you here?
And he has a lot of problem with his connection. But I think the point was, how do you reconcile open science for, I'm going to put quotes, fast science and slower science or longer term science? I think that was what he was trying to get at.
Yeah, I think that's an interesting challenge again. I mean, open science doesn't mean just releasing everything, removing my rights and my copyrights on what I release. It just to me, it's more providing to the society all the benefits of my research. Modulo, obviously, any particular restrictions that might be necessary to protect personal data or I don't know, patents or things like that. But I agree that in the spirit of fast science, as you name it, Florence, there's a that's a big question for debate. I don't have an answer for this, but it's definitely an interesting point.
All right. So yeah, and I think we can move on to Florent's presentation of the video contest, unless there are any further comments, which I think not. So yes, Florence, the floor is yours.
Okay. All right. I'm trying to put my video. All right. So I think you see my presentation. So I'm just going to talk very briefly about the short video contest that we organized. So the goal of that video contest was to provide a general presentation aimed at the greater public in the still in the spirit of RRI and public engagement and education of your research project. And the technical aspects of the video contest was providing to us videos of a maximum duration of 3 minutes with, again, a clear explanation in layman's term on your project and the main goals and or achievements. We were very happy to see that we had actually 14 submissions. We didn't know how many, it's the first time we do it, so we didn't know how many videos we would get, and we were very happy to have these 14 submissions from these projects that you see here. These have all been published on the website that is on the here on this lower, and I will also put the link in the chat. Please, if you can, tonight or tomorrow morning, if you have nothing else to do, look at the videos. You can vote. The voting should be open now, normally. You can vote for up to 3 videos, so 3 of your favorite videos. Please, we'll check. Don't vote for your own project. We will ask you to say which project you're with. Your vote will not be counted, and I don't, that's not the idea of the video contest. The video that has the most votes will have a special feature on the CHIST-ERA website and our other diffusion platforms. And the voting, as I said, is now open, and it will close on Wednesday at 3 p.m. so that we can compile the results. So have a nice viewing, and let's vote.
Thank you very much, Florence. Okay, so I hope that all of you will vote in this video contest, and I'm looking forward to finding out about a winner on our last day of the conference. And now we can just move to the last part of our today's program. So let me share my screen again. Okay, so yes, again, as I said before our first networking break, we are again moving to the Wonder platform. Here we have saved an hour from a program for the networking, but really it's entirely up to you how long you stay. The platform stays open non-stop, so you can be there even when the host is not present. And we are now again sharing the link to the networking platform and the password in the chat of Zoom. So all you have to do is click on the link, enter the password, and answer the icebreaker question. And that's a question that the answer to which will be visible to all of the other participants of the networking session. And then moving around in Wonder is very easy. So you just have to click and hold. And once you move closer to another participant, you will be able to see a circle which is created where you can video chat with others. So you will see different thematic areas in the room. You can move around these and based on your topic of interest, and you can discuss these topics with your colleagues there. And just note that camera and mic can only be used on one of those communication platforms at once, but since we'll be leaving Zoom after this presentation, I presume it won't be a problem in this case. So unless there are any questions on this, I think we can conclude this session. and I'm looking forward to seeing all of you at the Wonder platform. Thank you very much.